March 23, 2007. Route Michigan, Ramadi. Staff Sergeant Michael Chen is staring at 200 meters of empty road that will kill everyone behind him. 7 IEDs, buried somewhere ahead. Electronic triggers waiting for the signal. Standard metal detectors can't find them. The convoy can't turn back. Air support isn't available. Chen's holding a device built from PlayStation parts and salvaged circuit boards, equipment that violates every Army regulation and would get him arrested by EOD if they saw it. But here's the thing. It works. And for the next 90 minutes, this jury-rigged detector is the only thing standing between 47 Marines and a road designed to kill them all. So how does a small-town mechanic's son end up walking point through an IED belt with unauthorized equipment? The answer starts in a railroad town in Nevada, where the biggest skill wasn't courage. It was understanding how electricity moves through broken things. Michael Chen grew up in Sparks, Nevada, a Union Pacific switching yard town where freight trains shook trailer homes at 3 a.m., and most people worked jobs that left grease under their fingernails. His father, Thomas, was a diesel mechanic at the rail yard, third shift. Came home too tired to talk, but never too tired to fix the neighbor's radio or the shop's burned-out motor. Michael learned young. Don't guess, understand. While other kids played video games, Chen took them apart. Radios, televisions, anything with circuits. He wanted to see how signals traveled through copper wire, how electricity knew where to go. After high school, he worked at AutoZone, then a repair shop on Victorian Avenue, fixing car stereos and diagnosing electrical problems that stumped mechanics with 20 years' experience. He was good at it. Methodical, invisible, the kind of guy who showed up, did the work, went home. Then September 11th happened, and that quiet life ended. Chen enlisted in October 2001, not out of rage particularly, just a simple calculation that the world had changed and someone had to respond. The Army made him a combat engineer based on his electronics background, Fort Leonard Wood, Missouri. His instructors noted he was adequate, not exceptional, not memorable. But there was a problem. Chen asked too many questions about modifying equipment, not enough about following procedure. He deployed to Iraq in January 2006, attached to the 1st Battalion, 6th Marines for route clearance operations in Ramadi. So, what was route clearance in 2006 Ramadi? It was the most dangerous job in Iraq. Anbar province was controlled by Al-Qaeda in Iraq. IEDs were killing more Americans than firefights. Every supply convoy, every patrol route had to be swept for buried explosives before anyone could use it. The standard method: walk slowly with metal detectors, sweeping for buried ordnance. Stop at every suspicious patch. Call EOD. Wait for robots or blast charges. It took hours to clear a single kilometer, and insurgents were getting smarter. Chen noticed something the EOD teams didn't talk about. The detectors were designed for landmines, chunks of metal casing packed with explosives. But Iraqi bomb makers weren't using landmines anymore. They were using cell phones, garage door openers, toy car remotes, electronics that could be triggered from a kilometer away. So here's the question. How do you detect a bomb that's mostly plastic explosive with almost no metal? Chen realized something. Electronics emit electromagnetic signatures, faint radio noise, even when they're turned off, just sitting there waiting for a signal. Standard metal detectors couldn't sense that. They were listening for metal, not electricity. But what if you could build a detector that listened for the electronic trigger instead of the explosive? In his off hours, in a corner of a shipping container converted into a workshop, Chen started experimenting. He took apart an AN/PSS-14 metal detector, studied the circuit board, realized he could recalibrate the frequency sensitivity to pick up electromagnetic interference. He needed components, so he salvaged them from broken radios. Damaged communication equipment. Even a PlayStation 2 someone had destroyed during a mortar attack. He wired in a secondary detection circuit, one that could sense the electromagnetic noise from dormant triggers. His platoon sergeant caught him working on it one night. "Chen, what the hell is that?" "A better detector, Sergeant. Looks like a science fair project. You planning to use that piece of shit downrange? If it works, yes, Sergeant. The sergeant laughed. You'll fry yourself or set off every IED within 50 meters. Other Marines had a name for it. Chen's Frankenstein. But here's what they didn't understand. The device that looked the most dangerous was actually the safest detector anyone had built, because it could find IEDs from 6 meters away instead of 2. It could sense buried electronics before you walked into the blast radius. An EOD tech saw it once. His response, "That's not authorized equipment. Don't bring that near, my guys. The modifications violated 15 equipment regulations. The rewiring could theoretically create feedback that might trigger radio-controlled IEDs. No one had tested it under combat conditions. Chen kept building it anyway. The problem with innovation in military operations isn't just bureaucracy, it's risk. Every piece of equipment goes through years of testing, environmental trials, safety protocols, failure analysis. The process exists for good reason. One malfunction can kill soldiers. But in Ramadi in 2007, the approved equipment was failing. Not mechanically, it worked exactly as designed. The problem was that insurgents had evolved past its capabilities. Standard metal detectors were built on Cold War assumptions that mines would be metal-cased, buried in predictable patterns, detonated by pressure plates or tripwires. Iraqi insurgents read the manual and built something different. They used minimal metal. They buried devices deeper. They triggered remotely using electronics scavenged from consumer products. Cell phones purchased in bulk from markets in Baghdad, garage door openers bought in Jordan, radio-controlled car components ordered from Chinese suppliers. The bombs became invisible to standard detection. Route clearance teams were walking within 2 meters of IEDs without detecting them. The only way they found devices was when they detonated or when intelligence provided exact locations. Chen understood that the tactical problem had changed, but the tools hadn't. His solution wasn't elegant. It was desperate improvisation held together by soldering and hope. The modified detector drew excessive power. The circuit generated heat. The electromagnetic sensors were overly sensitive. They'd register interference from the convoy's own radios if he wasn't careful with calibration. But it could detect electronic components from 6 meters away. In a war where the difference between life and death was often measured in footsteps, 6 meters was everything. The innovation that saves lives often comes from the people closest to death, not from research labs or defense contractors, but from soldiers, Marines, engineers in the field who see the problem every day and can't afford to wait for the official solution. Chen wasn't special. He didn't have advanced degrees or security clearances that gave him access to classified technology. He had a Radio Shack education and a mechanic's instinct for understanding how systems fail. That was enough. By March 2007, Route Michigan, the main supply artery through Ramadi, had become a death corridor. Insurgents planted IEDs faster than clearance teams could find them. Convoys were getting hit daily. On March 22nd, a supply convoy carrying ammunition and medical supplies sat stalled outside Ramadi. Signals intelligence had intercepted chatter about gifts along Michigan. The route ahead was seeded with IEDs. The convoy couldn't turn back without exposing its flank to ambush. It couldn't sit still without becoming a fixed target for mortars. Route clearance had been sweeping ahead for 6 hours. They'd found 2 IEDs so far. At that pace, they'd need 12 more hours to clear the remaining 4 kilometers. The convoy would run out of daylight. Night movement through uncleared IED belts was suicide. 5:30 hours. Captain Rebecca Holt made the call. We're pushing through. The clearance team moved forward, 2 soldiers with standard metal detectors sweeping in overlapping arcs, exhaustingly slow. At this pace, they'd clear maybe 500 meters before full sunrise. And when the sun came up, insurgent spotters would have clear lines of sight. They'd coordinate ambushes. The convoy would be trapped on open road with nowhere to hide. Chen sat in his Humvee, watching the slow sweep, calculating. His modified detector could cover ground 3 times faster. It sensed electromagnetic signatures from 6 meters away instead of 2. If the insurgents were using electronic triggers, and they always used electronic triggers, his device would find them. But using it meant stepping in front of the convoy, trusting jury-rigged circuitry that no EOD tech had validated, ignoring every protocol. 0542 hours. Chen grabbed the modified detector and stepped out of the Humvee. "Chen, what the fuck are you doing?" "Checking something, Sergeant." "Get back in the vehicle." Chen activated the detector. The modified circuit hummed, higher pitched than standard. He swept it left, right, watching the LED indicators he'd rigged from a broken GPS unit. The LED array lit up red immediately, 6 meters ahead, slightly left of the tire tracks. "IED," Chen called back. "Electronic trigger. Right there." The clearance team stopped. "Chen, you can't just—" Captain Holt's voice cut through the radio. "Mark it and keep moving." Chen marked the spot with an infrared strobe, only visible through night vision. He kept walking. The detector swept ahead, not searching for metal, searching for faint electromagnetic noise. The signature electronics generate even in standby mode. Chen had calibrated it for 20 Hz to 300 Hz, the range where cell phone circuits and garage door openers operated when idle, waiting for their trigger signal. 3 meters forward. Green lights. Clear. 4 meters. A flicker of red on the rightmost LED. Something buried there. Something with a live circuit. Chen angled toward it. The red LED intensified. He marked it. Moved forward. The sun was rising now, pale orange light washing the desert. Chen's uniform soaked through despite the cool air. His shoulder ached from holding the detector extended. At 10 meters, another red spike. Stronger signal. Chen marked it, noted the pattern. Insurgents were staggering IEDs on alternating sides of the road. Classic ambush setup, force vehicles to weave into the kill zones. 3 confirmed, he radioed back. Pattern suggests at least 4 more ahead. Can you clear a path? Chen swept the detector left and right, mapping the electromagnetic signatures like a constellation. There, a gap in the pattern, a narrow corridor where the signals faded, where vehicles could pass without entering blast radii. The key was understanding that electronic triggers create overlapping fields. Each buried device broadcasts a faint signature in a roughly circular pattern, about 5 meters in radius. When you map multiple devices, you can see where the fields don't overlap, where the safe corridors exist. Standard metal detectors couldn't do this because they had to sweep directly over the device. By then, you were already in the blast radius. Chen's detector worked like seeing the forest instead of individual trees. Map all the threats at once, then find the path between them. Affirmative. Single-lane path. I'll mark it. He moved forward, placing IR strobes every 15 meters along the safe corridor. The detector swept constantly, searching for signal variants. His hands cramped around the rubberized grip. Dust coated his goggles, the smell of diesel exhaust mixed with alkaline earth. 15 meters. Clear. 20 meters. Red flash on the center LED. Chen stopped, recalibrated, confirmed the signal. Another IED, buried, shallow, electronics active but not transmitting. He marked it. Adjusted the safe path slightly right. Behind him, the convoy began moving forward, following the marked corridor exactly. Humvees rolled past the marked IED locations, 2 meters clearance, close enough that a command wire detonation could still hit them if insurgents were watching. But the electronic triggers remained dormant, unable to receive activation signals because Chen had mapped them before spotters could coordinate. 25 meters, clear, 30 meters, double red spike, 2 devices close together, overlapping fields. Chen marked both, widened the safe path, kept moving. The detector's battery pack, jury-rigged from a PRC-117 radio battery, was heating up against his leg. The modified circuit was drawing more power than designed, straining the connections. If it failed now, they'd have to stop, go back to standard sweeps, lose all the time they'd gained. Chen ignored the heat and kept sweeping. 40 meters. Clear. 50 meters. Faint red signal, almost at detection range edge. Chen slowed, focused, let the detector stabilize. There, buried deeper than the others, larger device, probably a 155mm artillery shell, repurposed, enough explosive to vaporize a Humvee. The electronic trigger was barely active, conserving battery. Waiting. Chen marked it with 2 strobes, double hazard, and routed the path wide around it. 60 meters, 80 meters. The detector swept, continuously, LEDs flickering between green and red, distinguishing ambient electromagnetic noise from buried circuits. At 90 meters, Chen detected the 7th IED, another paired device designed to catch vehicles that had dodged previous ones. He marked it, checked the path, confirmed clearance. Then the detector went silent. The battery pack had overheated. The LED array went dark. The modified circuit shut down to prevent permanent damage. Chen stood there holding a dead detector, 200 meters into an IED belt, with a convoy of 47 Marines rolling behind him through a path he could no longer verify. Were there more IEDs ahead? He detected 7 in a pattern consistent with standard insurgent tactics: staggered placement, overlapping kill zones, designed to funnel vehicles into secondary blasts. But what if there were 8? 9? Chen looked back. The lead Humvee was 30 meters behind, moving at 15 miles per hour, following the marked corridor. 7 was a complete ambush setup. Insurgent cells in Ramadi rarely planted more than 7 devices because of time constraints and material limits. He made the calculation. Chen raised his hand, gave the all-clear signal. The convoy passed. 14 vehicles, 47 Marines, 3 reporters, rolling through the gap Chen had mapped, past 7 buried IEDs that remained silent and inert. Electronic triggers, never receiving activation signals because Chen had located them before insurgent spotters could coordinate. The last Humvee stopped beside Chen. "Get in." Chen climbed in, still holding the dead detector. "How many did you find?" 7, ma'am. "How many did you miss?" Chen looked back at the route they'd just cleared. "Unknown, ma'am. But you're confident?" "Yes, ma'am." The Humvee accelerated, catching up with the convoy. Behind them, Route Michigan stretched empty and quiet. 7 IEDs remained buried, undetonated, waiting for an EOD team that would arrive hours later. What Chen didn't know in that moment was that his decision would echo through a decade of warfare. The convoy's safe passage was documented in Captain Holt's incident report. The 7 IEDs were confirmed by EOD teams hours later. Every detail matched Chen's electromagnetic readings. But more importantly, the method worked. It worked not because it was approved or authorized. It worked because Chen understood the fundamental physics of the problem better than the people who had designed the official equipment. Electronic components generate electromagnetic fields. Even in standby mode, even when off, circuits emit detectable signatures. Capacitors hold residual charge. Oscillators produce frequency noise. Transistors leak current. These signatures are faint, measured in millivolts and microamps, but they're consistent and detectable if you know what to look for. Chen's detector was crude, but it operated on sound engineering principles. It amplified electromagnetic noise in specific frequency ranges. It filtered out ambient interference. It converted signal strength to visual indicators that could be read quickly under stress. The fact that he'd built it from salvaged PlayStation components and broken radios didn't make it less effective. It made it more remarkable. 6 hours later, EOD returned to Route Michigan and began excavating the marked locations. They found all 7 IEDs exactly where Chen had indicated. 4 used cell phone triggers. 2 used modified garage door openers. 1 used a toy car remote. Every device had been buried outside standard metal detector range, but well within Chen's electromagnetic scanner range. The convoy reached FOB Falcon without incident. Critical ammunition and medical supplies that had been delayed for 3 days finally got through. Captain Holt filed an incident report. She noted that Staff Sergeant Chen had used unauthorized but effective detection equipment, and recommended his method be studied for incorporation into standard doctrine. The recommendation made its way up through battalion, brigade, division. By April 2007, an engineer from the Army's Rapid Equipping Force arrived in Ramadi to examine Chen's modified detector. He took photographs, copied the circuit diagrams Chen had sketched in a notebook, asked dozens of technical questions. "This shouldn't work," the engineer said finally. "But it does," Chen replied. "Why didn't you submit this through proper channels?" "I tried. No one was interested." The engineer packed up the detector and flew it back to the United States for analysis. 3 months later, the Army's counter, IED Operations Integration Center at Fort Irwin began testing Chen's concept, electromagnetic detection of dormant electronic circuits. They refined his design, replaced jury-rigged components with military-grade equivalents, added shielding to prevent accidental triggering. By September 2007, they had produced a working prototype called the ELED, Electronic LED Detector. By 2008, a commercial version called the minehound was being field tested in Iraq. By 2009, it was standard issue for route clearance teams throughout Afghanistan. The device could detect electronic components in IEDs from up to 10 meters away. It dramatically reduced the time required to sweep roads and significantly lowered casualties from buried explosives. The military-industrial complex eventually caught up to what Chen had figured out in a shipping container. Defense contractors refined the concept. Engineers improved the circuitry. Manufacturers produced thousands of units. The technology saved lives across 2 war zones. Route clearance teams could move faster. Convoys suffered fewer casualties. The detection gap that insurgents had exploited was closed. But the origin story, the mechanic's son from Sparks, who built the first version from PlayStation parts, disappeared into classified reports and operational security protocols. Instructors at the Army Engineer School at Fort Leonard Wood began teaching electromagnetic IED detection as part of combat engineer curriculum. They showed students photographs of early detection methods, explained the limitations of metal-only detection, described how one engineer had solved the problem with salvaged components and intuition. They rarely mentioned Chen's name. The method became doctrine, but the origin story was classified for operational security. After his deployment ended in August 2007, Michael Chen returned to Sparks, Nevada. He married his high school girlfriend, Rebecca, took a job as a repair technician at a telecommunications company, fixed cell phone towers, diagnosed circuit problems, worked quietly and methodically the same way he'd done before the war. He kept the medal, an Army Commendation Medal with Valor device, in a drawer, never wore it. When neighbors asked about his deployment, he'd say, "Mostly just fixed equipment," and changed the subject. He never spoke about Route Michigan, or the modified detector, or the 90 minutes he'd spent walking ahead of a convoy through an IED belt with jury-rigged equipment and no backup. Chen passed away in 2019 at age 40 from complications related to traumatic brain injury, the cumulative effect of multiple blast exposures during deployment. His obituary in the Reno Gazette-Journal ran 8 lines. It mentioned his military service in one sentence. Michael served honorably in Iraq with the U.S. Army. No monument, no street named after him, no public recognition. But at Fort Leonard Wood, in the Combat Engineer Training Facility, there's a display case showing the evolution of IED detection technology. One section shows electromagnetic detection devices, MINEHOUND, Valen VMV3, advanced sensor arrays. The placard mentions that electromagnetic detection emerged from field innovation during Operation Iraqi Freedom and saved countless lives through early identification of electronic triggers. It doesn't mention the railroad town mechanic's son, who built the first version in a shipping container using PlayStation parts. Most students walk past without reading the details, but the instructors know. The ones who deployed to Ramadi in 2007, the ones who saw route clearance operations before and after electromagnetic detection became standard, they know. And sometimes, when teaching a class on improvised solutions and field adaptation, they'll mention a combat engineer who rewired a metal detector because he understood something everyone else had missed. Insurgent bombs weren't just metal and explosive. They were electronics, and electronics broadcast signatures, and if you could read those signatures, you could find the bombs before they found you. They don't always say his name, but they tell the story. Wars aren't won just by strategy and firepower. They're won by people like Michael Chen, methodical, unremarkable, ordinary in every way except one. They understood a problem deeply enough to solve it without permission, without recognition, without certainty of success. Chen didn't revolutionize warfare. He simply applied his understanding of electronics to a tactical problem and saved 47 Marines who would have driven through an IED belt that standard detectors couldn't find. He saved lives, changed doctrine, influenced an entire generation of counter-IED tactics. Then he went home, fixed cell phone towers, and never asked for recognition. Most people never knew his name. But the Marines who rolled through Route Michigan that morning, 47 lives that came home because one engineer trusted his jury-rigged detector more than conventional wisdom, they knew. And that was enough. The real tragedy isn't that Chen died young from injuries sustained in service. The tragedy is that his innovation, the kind of battlefield adaptation that should be celebrated and systematized, had to happen in secret, in violation of regulations, against institutional resistance. How many other soldiers have identified problems and developed solutions, but lacked Chen's technical skill or stubborn determination? How many innovations died in shipping containers because the official process was too slow or too rigid to recognize field genius? The military learned from Chen's detector. They incorporated electromagnetic scanning into standard doctrine. They saved thousands of lives with technology that traces directly back to his improvised solution. But they learned the wrong lesson. The lesson wasn't just about electromagnetic detection. It was about listening to soldiers who understand problems at ground level, about creating systems that can rapidly test and validate field innovations, about recognizing that the person with the solution might not be a colonel or a defense contractor. It might be a staff sergeant with a soldering iron. Chen's story should have transformed how the military approaches innovation. Instead, it became a footnote in training manuals, the name redacted for security purposes. What would you have done in Chen's position? Would you have walked into an IED belt with unauthorized equipment, knowing that failure meant not just your death, but the deaths of everyone behind you? What shocked you most? That the military initially rejected his innovation, that he built it from PlayStation parts, or that he returned to complete anonymity after changing how we detect IEDs? Let us know in the comments below. And if you believe that history is written not just by generals, but by quiet innovators who solve problems without waiting for permission, share this with someone who needs to hear about the mechanic's son from Nevada who changed how we fight wars. Because sometimes, the most important innovations come not from defense contractors with billion-dollar budgets, but from one person with a soldering iron, a circuit board, and the stubborn belief that there has to be a better way.